My dear students, this is your science friend Srinivas. So, this is a loudspeaker. I wanted to make you understand how this loudspeaker works. See, there's a magnet here, and here is a magnet, okay? And here is a electrical connection. Because you all know that loudspeaker is a device which converts electrical signal energy into sound energy. So whatever is coming out of the amplifier, the amplified audio signals are connecting at these points. And then, what is the mechanism happening here? See, here, now you can see there's a paper here. This is a paper cone, okay? So that has to vibrate. Then only you can hear the sounds produced by this loudspeaker. But how this is going to vibrate? We are giving electrical signals, amplified signals to this loudspeaker. So there is a magnet. As you have already seen, there is a magnet here behind. So that's a permanent magnet. So permanent magnet offers a permanent magnetic field in which we need to do something. So then only you can get the required vibrations from this paper cone. Okay. It is one way suspended in a frame, a metallic frame. You can see there's a metallic frame. Okay. Totally. There's a metallic frame. So all this, the black metallic frame is helping to keep the paper cone and a kind of spring action inside and a coil, electric coil, and then the magnet. All together, they are very much placed properly in the metal frame. Okay. Now, what happens? You all know that if at all electrical energy in a coil kept in a magnetic field and the coil vibrates, the moves to and fro. So for that the required permanent magnetic field is given by the permanent magnet here, and we need to produce electromagnetic effect. So that effect from the amplifier output we will be connecting here, and these two wires are connecting to a coil inside the speaker. You want to see the coil? No problem, I can show you. Okay, I'll ask my Kalyan to hold the frame and then ask him to remove the magnet. Yeah, now the magnet has come, my dear friends. You see, it is attracting. The total speaker assembly, it is attracting. Okay. You see, say here is a permanent magnet, and inside this permanent magnet you can see a groove, circular groove, in which this coil is placed. So what happens whenever you give electrical signals here, and there's a change in electric field here. When it is placed in a solid material, then automatically electromagnetic effect is produced. Okay, so when electromagnetic effect is produced, and that is produced according to the given audio frequencies, amplified electrical currents. So based on this vibrates. Okay, because this is placed here in this circular disc, in the groove, and there is a core here. So when this particular coil is placed inside this coil in core, then what happens? And whenever there is a electrical currents flowing one direction to the other direction, the way they changes the direction, the way they changes, according to that, there is a magnetic repulsion and attraction, because there is a permanent magnetic energy is already applied here. In the magnetic field, permanent magnetic field, when electromagnetic field is attracting or repulsions are taking place, when they are repelled together or they attract together, simultaneously attraction and repulsion together, there's a displacement, there's a vibration of this coil. When this particular vibration takes place in this coil, automatically this coil is very much connected. Now I am going to show. You see the coil inside, it is very much connected to this particular paper cone. So whenever there is a vibration in this coil like this, to and fro, okay, so automatically this paper cones vibrates. When paper cone vibrates, that's it. The physical sound waves are produced in front of the paper cone. You know how they reach your eardrum, and that's it. You will hear them in the ear. From there to your brain, all that you know. Okay? So this is the internal mechanism of any loudspeaker, how it works like. Interesting, no? So I must thank one of my friend, Mr. Sai, for giving me this particular speaker to open it and show you. Interesting. So I hope you understand. And now and then, my dear friends, my dear students, whenever you find a faulty speaker, you can open it up and you can see the coil is no more in connection. So whenever huge current flows through this coil, that means suppose the speaker power handling capacity is suppose say 20 watts, and you connect to a 50 watt or 100 watt amplifier and you give full volume, then a huge current try to flow through this particular coil, this copper enamel insulated coil. Then what happens? The coil will short circuit. When the coil is short circuited, okay, and then the electromagnetic effect is not going to take place. Then there is no vibration, no sound produced, physical sound produced is not going to be there. Okay, so you need to understand. So at that time, you need to replace this coil. And also for replacing the coil, so usually everybody what they do is they cut the paper and they remove the paper cone. From there they remove the coil. Okay, and then they replace a new coil and again they put a new paper and they stick it with some adhesive materials. Okay, I can do one video about that, how to do. Already there are many videos how to repair the speakers and all. But to make you understand, I feel really you all will exercise with the faulty speakers, or even the ones working. You can open them and see inside how they are all working, how the magnetic energy is between the permanent magnetic energy to the electromagnetic energy, how they repel, how they attract. All these things you can verify, and physically you touch them and feel on a paper core. That's where the invisible electrical currents, electrical signal amplified currents, are physically producing as a sound wave. This is how, my children, you all need to get explored. So let's explore the in and around, if and all this stuff like that. So I hope you enjoyed understanding how the loudspeaker works. So thank you. Signing off, your science friend from scientificstudents.com.